Hlokomelo, how's it hlokomelo? Hlokomelo, can you tell me why are you liking the live? Why are you liking the live, Hlokomelo? Hello, Taps, is it Tapis by? Is it Tapes by? Yeah. Kumo, how's it, Kumo? The sum of three consecutive integers is 99. What is the value? What is the value of the smallest of these three numbers? The sum of three consecutive, the sum of three consecutive integers is 99. What is the value of the smallest of these three numbers? The sum of three consecutive integers is 99. Yeah, word problems are very interesting if you ask me. They're very interesting. But as interesting as they are, learners need to develop the skill of being able to know how to navigate through word problems. Okay. And the sort of like as a strategy or approach of attending to word problems, it's important to assign what we call a variable. We assign a variable to the thing that we're looking for. Now, a variable is a letter of the alphabet that stands in the place of something we don't know. So when I say we assign a variable to what we want to find, then of course we interpret the info that is basically given to us. We interpret the info and represent it in mathematical language. Mathematical lingo. Yeah. So assign variables to what we want to find. We interpret the info and represent it in mathematical lingo. And then, yeah, hopefully we can set up a few equations through that. Hopefully we can set up an equation or equations, depends, could be plural, could be singular, and then solve for what we need to solve for, and then by so doing answer the question. So for instance, let's look at this problem specifically. This is saying the sum of 3 consecutive integers. Now when they talk about the sum, what are they talking about when they say the sum? Let's not go any further. Do we understand when they say the sum what they are talking about? What is it? When we say the sum of something, mathematically, what are we saying as far as the symbol that represents the sum of something? Okay, so the sum means, obviously, right? You can see many of you are like, Suka, sum means this. Okay, sum means that. So hopefully we can see a symbol in our heads, a symbol like the cross, because sum means the addition, the total, the all together. So sum means, there's your symbol. So the sum of 3, how many? 3 what? Consecutive integers. What does the word consecutive mean? The word consecutive means one after the other, one following the other, one after the other. So the sum of 3 consecutive. Now consecutive what? Integers. What are integers? Integers are your positive and negative whole numbers. Your positive and the negative whole numbers. So for instance, 0, 1, 2, 3, 4, 5, that would be like your positive whole numbers, right? But then negative, you say negative 1, negative 2, negative 3. These basically are your integers. From negative infinity to positive infinity, we increase and we decrease by 1. So integers increase and decrease by 1. Integers are your family of numbers that consist of positive and negative whole numbers. That's what integers are. So let's relook at the statement again. The sum of 3 consecutive integers. So that means these are integers that follow one another, one after the other, one after the other, these integers. But do you know these integers? Do you know the actual integers? No, we say we are just told the sum of 3 consecutive integers is 99. The what? The sum of 3 consecutive integers is 99. Now the question is, do I know in the sum of these 3 consecutive integers, do I know what the first integer is? No, I don't. So I let x be the first integer. I let x, so I use any variable. Guys, you could use p, you could use n, you could use l, you could use d, you could use e, you could use n. You let whatever be the first integer. So we are assigning a variable to what we want to find, because a variable like x stands in the place of something we do not yet know specifically, but we assign the variable to stand in the place of that thing that we don't know. So currently what we don't know is the actual integers, the actual values of these integers. We don't know them yet. So we're saying the sum of 3 consecutive integers. So if the first integer, guys, is x, then with your knowledge of what you know about integers, for instance, let's say we knew specifically that the first integer is 1. So if it would be first 3 integers starting from 1, then the next one would be what? It would be 2. Then the next one would be what? It would be 3. Does that make sense? If these integers, let's say the first integer was -2, what would be the next integer? It would be -1. What would be the next integer? It would be 0. I'm just saying if we knew specifically, but we don't know specifically. We are just told the sum of 3 consecutive integers is 99. So firstly, let's first define, using a variable, what the first integer is. So we let x be the first integer. If the first integer is x, what would be the second integer be in terms of x? If this is the first integer and it is x, then the integer that follows this one would be what, guys? What would it be? Okay, we know integers, they increase and decrease by 1. So if the first integer is x, then it means that my second integer is going to be x plus 1. That would be my second integer in terms of x. And what would be my third integer be? Okay, my third integer, okay, all I do, I simply add 1 to the previous one. So my third integer would be x plus 2. So there we have it. There we have it. Okay, let's go back. The sum of 3 consecutive integers is 99. So once again, firstly, before I talk about anything else, because I want to first assign a variable to what I want to find, I wanted to first understand what would be the first integer, since I don't know what it is. So I assign a variable, I let x be the first integer. Since there are 3 consecutive integers, meaning integers that come one after the other, if the first one is x, what would be the second integer? We simply add 1 to the previous integer, so that would be x plus 1. What would be the third integer? Since the second integer is x plus 1, we simply add 1 to the previous integer, we get a third integer of x plus 2. So if we go back again, we have defined, using the variable x, the first 3 integers. It's x followed by x plus 1 followed by x plus 2. Now let's reread again. This thing is saying the sum of 3 consecutive integers is 99. Okay, now we are going to, having assigned the variable to what we want to find, we are now going to interpret the info and represent it in mathematical lingo by setting up an equation. So let us interpret the sum. What does the sum mean? It means the addition of what? Of the 3 consecutive integers. What are these 3 consecutive integers? It is x plus, because of the sum, x plus 1 plus x plus 2. So let's go reread again. The sum of 3 consecutive integers is 99. So here currently we have what? The sum of what? The first 1, 2, 3 integers that are what? That are consecutive. X plus x plus 1 plus x plus 2. The sum of 3 consecutive integers is 99. So the sum of these 3 consecutive integers is, means equal to 99. We have just set up our equation. There it is. X plus 1 plus x plus 2 equal to 99. Let's go reread again. The sum means plus, of three what? Consecutive integers. What are the consecutive integers? Since we don't know them specifically, we need to generalize the integers by letting x be our first integer. As I said, we assign a variable to the first integer. The consecutive integer from x will be x plus 1, because integers, they increase and decrease by 1, but the next one would be increasing by 1. Hence, from x, the second integer is x plus 1. Then this also will increase by 1 to give me the next integer, the third integer, which would be x plus 2. So they are saying now what? The sum of those three consecutive integers. So I take these integers, x being my first, plus x plus 1 being my second, plus x plus 2, which is my third. What am I further told? The sum of three consecutive integers is 99. This is means equal. That's why we have an equal sign to represent is. 99 is on the other side. So the sum of these three consecutive integers should give me 99. Full stop. Equation written down. What is the value of the smallest of these three numbers? So in other words, what is the value of? Now, out of these three integers, which one would be the smallest? Is it x? Is it x plus 1? Or is it x plus 2? Which expression defines the integer value which would be the smallest? Right? Hopefully, your thought process is leading you to conclude about a specific variable which would represent the smallest of these three numbers. It would obviously be which variable? It would be the variable x, because it is the first integer. The subsequent or consecutive values are obviously increasing by 1, which means they are greater than the first variable. So therefore, what we will do is we are going to solve this equation. So now it's time to solve the equation, and to do so, we apply our solving the equation rules that we know whenever we want to find an unknown. So we're going to say x plus the 1 that is outside here distributed to the x is going to simply remove the bracket, and we are going to have x plus 1. The 1 that is outside this bracket is going to be distributed and simply remove the bracket, so that we have x plus 2, which is equal to 99. Then we isolate the variable x plus x plus x on the left hand side. Of course, we transpose 1 and 2. 1 is positive, the 2 is positive. We transpose those values to the right hand side, and when that happens, the positive 2, which I would want to remove using what I call the additive inverse. If you want to remove plus 2, you subtract 2. But with equations, whatever you do on the left, you do on the right. Hence, we simply speak about transposing or moving the 2 over to the right-hand side, and the sign of that particular term changing from whatever it was per the sign to another sign. So if you are subtract 2 on the left, you have to subtract 2 on the right. Obviously, the subtraction of 2 here on this side leads to 0. Subtraction of 2 that side will obviously lead to a specific value. We have positive 1 this side. So if you want to get rid of positive 1, you subtract 1. But what you do on the left, you do on the right, meaning you'll also subtract 1 this side. So We simply shortcut the process and we say we transpose 1 to the right, positive 1 becomes negative 1. We transpose 2 to the right, positive 2 becomes negative 2. Then now we can add the like terms on the left and add the numerical values on the right. X plus x plus x will give me what specifically? X plus x plus x. It's like we're adding kids that are wearing the same X uniform. The uniform stays the same, it never changes, meaning X will remain like that. We then add the coefficients, meaning the numerical values that come before the letters. 1 plus 1 plus 1 is 3, so therefore the answer is 3x. On the other side, 99 minus 2 minus 1, which is 99 minus 3, gives us 96. From there, we're now going to apply what we call the multiplicative inverse. We do what to get rid of 3? We apply the inverse operation. 3 is multiplied to x. So to get rid of 3 that is multiplied to x, we divide by 3, both left and right. Yes, Ruben. Then our final answer, as Ruben has indicated in the comments section, is 32. And that 32, what does it actually stand for? Remember, we did let x be the first integer of the 3 consecutive integers whose sum is 99. We want to know the value of the smallest of these 3 numbers. The value of the smallest of these 3 numbers is represented by the x value, which is the first integer. So we know x is 32. That therefore means the smallest. We now answer the question as it being, what is the value of the smallest of these numbers? The smallest of these numbers is 32, because our x value as the 3 consecutive integers, which we were told the sum of those 3 consecutive integers is 99, we know that the first value, x, which is unknown, represents the smallest integer out of the 3 integers. And that's that. Done, dusted, not a problem. The first word problem answered like a pro, and all we simply did, guys, was number 1, assign variables or letters of the alphabet to what we want to find. X is very popular and common. It is used often to basically, and it is assigned to find what we do not know. That does not mean we cannot use other letters. We are free to use other letters. It's just that X has prominence. We interpret the information and represent in mathematical lingo what we basically have as the info. We then set up an equation or equations, then we solve for those and then answer the question, which is what we typically did here in this particular scenario. Okay, let's look at another problem, because in word problems, guys, both grade 10 and 11, your word problems do contain your number type of problems. So we call these your number type. This has to do with your numbers, integers, real numbers, basically your number system. These are your number type of word problems. Okay, now let's change the channel a little bit here and look at your age type of word problems, and then see what that has to bring for us. So let us first write down our scenario. A mother is currently 4 times as old as her daughter. A mother is currently 4 times as old as her daughter. I wonder how old you are, mother, from your daughter, if you are a mother. In 5 years' time, she will be 3 times as old as her daughter. What is the daughter? What is the daughter's current age? A mother is currently 4 times as old as her daughter. In 5 years' time, she will be 3 times as old as her daughter. What is the daughter's current age? So what we do here, we assign, as I had said, as per a general strategy, assign variables to what we want to find. What do we want to find? We want to find what is the daughter's current age. So current means now. In 5 years' time means later. So let us say then, let X be the age of the daughter. Let X be the age of the daughter. Now I want to be able to collect all the other necessary information because, and in collecting it, I want to tabulate it before I set up an equation. This is part of interpreting the info and representing it in mathematical lingo that we will get to and set up equations and so forth. But for starters, I want to assign the variable to what I want to find, and because here we are told what is the daughter's current age, they want to know what the daughter's current age is. So we are going to let X be the age of the daughter. Okay, let X be the age of the daughter. So let us then tabulate this information. We are going to first talk about, or we are going to collect, because we have 2 people here, the daughter and the mother. So let's just say daughter and mom. Now, or we could say currently, okay, the current situation, and then we also have the 5 years time scenario or situation. Okay, that's future. So we have now and future. So let's just look at what we have said as far as now with the daughter's age. Let's go reread. A mother is currently 4 times as old as her daughter. Okay, yeah, so currently a mother is, mom is what? 4 times as old. When we say 4 times as old, let's say I am 10 years old. Okay, if my dad is 4 times as old as me, let's say I'm 10, that means my father is what? How old is my father? If I am 10 years old and my father is 4 times as old as I am, how old is my father, guys? Do you guys know what 4 times implies? Because I need you guys to understand the wording and its implication. A mother is currently 4 times. If I am 10 years old and my father is 4 times as old as I am, how old is my father? Thank you, Brenda. Vulindlela Yo, Brenda, you are vulnering the ndlela, hey? Now you are just bringing back fussy days, hey? A mother is currently 4 times as old as her daughter. So what did we say? We let X be the age of the daughter. So daughter is X years old. That means mommy, if mommy is 4 times as old as daughter, that means we can take the age of the daughter, which is X, multiply by 4, because the 4 times the age of the daughter will be representing the age of mommy. So in other words, we can use the expression 4x as to define mommy's age currently, 4x, whereas daughter's age currently is X years old. So daughter is X years old while mommy is 4x years old. Does that make sense, guys? I hope so far we are kind of getting the flow of me using a variable to define what I want to find. Daughter's age, X. Mommy's age, since mommy, we are told, is 4 times as old as daughter, then we can say 4 times daughter's age, which is what? X. So 4x is basically the expression that represents mommy's age. Now let's read further. We are told, in 5 years' time, she will be 3 times as old as her daughter. Now, let's come here. In what? In 5 years' time. Now, let's forget about all the other things. But in 5 years' time, if we look at the fact that daughter's age currently is X, mommy's age currently is 4X, in 5 years' time, what does that mean? I need you guys to understand what that means. If I am 10 years old right now, in 5 years' time, how old will I be? That's what I need to find out from you guys. If I am 10 today, in 5 years' time, how old will I be? And if my daddy is 40 years old currently, how old will he be in 5 years' time? Thank you, Brenda. If I am 10 years old right now, in 5 years' time, I will be 15 years old. If daddy, my father, is 40 years old, in 5 years' time, he will be 45 years old. So thank you so much, Brenda. Yeah, Brenda is like opening up the way, all the way. So therefore, that means if the current age for my daughter is X, then in 5 years' time, I can say X plus 5. Brenda gets the point that we add 5 years to the age that we have currently. If mom is 4x years old, then what do? I add 5 to his age. You see, to mommy's age as well. So my table, guys, it's satisfying. This is all part of the interpreting the info and representing it in mathematical lingo. We call X a variable. What is a variable in mathematics? A variable is a letter of the alphabet that stands in the place of something we do not yet know. It's not yet revealed to us, but we know generally, okay, it's the age. What is the specifics of the age of the daughter? We don't know. So it is our opportunity to find out or to solve what the age of the daughter is. And we are getting there. We're getting there so nicely. Okay. All right. So currently, as I said, daughter's age is X. Mommy's age is 4X. In 5 years' time, daughter's age will be X plus 5. Mommy's age will be 4X plus 5. Now, let's go back and reread the statement in the hopes of doing what? Equation time, baby. Equation time, baby. We want to set up our equation so that we can solve. We don't have one yet, just a set of expressions, which is basically tabulated nicely. I think we are good to go. Let's go check now. In 5 years' time, this is speaking about mommy. In well, let's go and reread from the beginning. A mother is currently 4 times as old as her daughter. Ne? That one we have captured now. We've captured it. We said let daughter's age be X, let mommy's age be 4 times X. This one is captured. In 5 years' time, she will be. Okay, even before we jump into the specifics, when we say in 5 years' time, already, guys, I mean, daughter's age was X, so in 5 years' time, we know it will be X plus 5. Mommy's age was 4 times X, or 4X. In 5 years' time, it will be 4X plus 5. That one we understand. We understand why we have these expressions in 5 years' time. Now, in the hopes of setting up our equation, let's reread and set up a reasonable equation which we can solve. In 5 years' time, she, speaking of mommy dearest, will be 3 times as old as her daughter. Let's reread this thing. In 5 years' time, she, who is she? Mommy dearest. Mom. She will be what? 3 times as old as her daughter. But this is only going to happen when? In 5 years' time. So let's go to our expressions of in 5 years' time. Where is mommy's age? There it is. It's 4x plus 5. I'm going to take that 4x plus 5 and write it down because look at this. In 5 years' time, she, speaking of who? Mommy, will be. I repeat again. In 5 years' time, she, who? Mommy, will be 3 times as old as her daughter. 3 times. 3 times what? 3 times as old as her daughter. What is daughter's age in 5 years' time? X plus 5. 3 times X plus 5. Read it again. In 5 years' time, she, speaking of who? Mom, will be what? 3 times what? As old as her daughter. Let me just read again. In 5 years' time, remember this 4x plus 5 is an expression that represents mommy's age in 5 years' time. She will be. She will be. Will be means equal. She will be 3 times 3 multiplied as old as her daughter. This expression of x plus 5 represents the expression for the age of the daughter in 5 years' time. So all in all, we have 4x plus 5. An equation that is 4x plus 5 is equal to 3 into x plus 5. This equation, we are going to solve for x. And the x value that we get will be the age of who? Let x be the age of the daughter. What do they want? What is the daughter's current, meaning the now age? We want the value of x anyways. Okay. Thank you, Brenda. Brenda, you're following very nicely. 4x plus 5 is equal to, you take the 3, you distribute him inside the bracket. Guys, the expression x plus 5 and 4x plus 5, when there is something like 3 that is multiplied to the expression, we must be careful to make sure we put brackets around the binomial expression. Because if we don't, guys, if we simply do this 3 times x plus 5, it's easy to think that according to BODMAS, 3 is supposed to only be multiplied to x, and then afterwards we add 5. And that is not the case for the expression of x plus 5. So please be careful and put brackets around your expression, especially if there is a numerical value that is coming before that particular expression and it has a relationship of multiplication. Please, 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 because the difference between 3 times x plus 5 and 3 with a bracket into x plus 5 is that this 3 gets distributed to both terms. So we have 3x plus 15. Whereas here we would have 3x plus 5, and without the 3 being distributed to the 15, we wouldn't be, to the 5, we wouldn't be true to the solution that we need to get in order to get the age of the daughter. So now the equation, it's easy to solve it. This is a linear equation. And with linear equations, guys, what are linear equations? These are equations that have the variable x to the power 1, guys, there as their variable. That's linear. The minute you have x to the power 2, it's not linear anymore, it's quadratic. The minute you have x to the power 3, it's no longer linear or quadratic, it is cubic. So you must be aware of the type of equation you have. Linear equations, we simply solve by isolating the x variables on the left, and then we take the numerical values to the right. When 5 goes over, it transposes, becomes negative 5. X is equal to 10. This 10, what does it represent? It represents the age of our daughter. The age of the daughter's current age. The daughter's current age is 10 years old. That's what they wanted most. They wanted the daughter's current age. And we know that now column, the x value for daughter will represent the current age. Had they asked us to find the age of the daughter in 5 years' time, if the question had said here at the end, what is the daughter's age in 5 years' time, then we would have had an interest of taking that 10 and substituting it here under the expression of 5 years' time. Then we would have gotten a different age for the daughter. Okay, so that's why when you read your problem, you must be very much in tune with what is being asked and what you need to be answering, so that at the end you can make the appropriate conclusion. If they had said they wanted the age of the mother and the daughter, we would have concluded and said the daughter's current age is 10 years old, and then the mother's current age, we multiply the 4 with the 10, 4 times 10, that would mean that the mother is 40 years old. So all in all, what I'm saying, guys, is that you answer the question specific to what is being asked. So I again appeal to you that when we do word problems, there's a strategy that we follow with word problems. Yes, the mom would be 40, Brenda, 100% correct. We always assign the variable to what we want to find. We interpret the info and represent in mathematical lingo. Sometimes you will use a table to be able to do all of that so that your collection of information is all in one place. Then you reread the statements again so that you can set up your equation that is relevant to the problem, and then you solve, and then you answer the specific question in words. Because remember, at the end of the day, this X, even though we know it represents the age of the daughter, at the end of the day, you need to answer the question that was asked. Hence, you see me say the daughter's current age is 10 years old. This was a word problem. Therefore, it needed me to then make the appropriate conclusion as we see fit. So far, guys, in these word problems, we've looked at the number type word problems, and we saw how to deal with those. Then now we were busy with the age type word problems, and we saw how those ones actually unfold. And we even got the answers that were actually being asked for. Confidence. What a confidence booster. Okay. Now, let us turn our attention now to a different story. Brenda. Oh, Brenda is featuring in a word problem. My goodness. Golly gosh. Let's look at what Brenda did. Brenda allocated an amount of money. An amount of money. You see now Brenda is working with money, is like he allocating money to spend. My goodness, I wonder what does Brenda want to spend that money on. Brenda allocated an amount of money to spend on calculators. I'm saying Brenda, because Brenda is obsessed with making sure that things are accurate, is spending, is allocating an amount of money to spend on calculators. To do what? That she will donate to a charity. Brenda is very hurt that in some township schools, some learners simply just do not have a calculator. So she's intending to donate those calculators to a charity organization, so that that charity organization can begin to distribute calculators, providing children with stationery. Man, do you see how generous Brenda is? Yeah. She considers two different what? Two different brands. Yeah. Because these calculators, there are different brands that these calculators have, mostly. Two different brands. The first brand A, Casio calculators. They sell for 300 Rand each. Okay, that's Casio calculators. Brand B, your Sharp calculators. They actually sell for 500 Rand each. Okay. Then here's the thing. If she chooses brand A, okay, she can buy what? She can buy 16 more calculators. 16 more calculators than she can buy if she chooses brand B, or your Sharp calculators, as you saw brand B is. The question now is, how much moolah or money or zaga, how much moolah, money or zaga has Brenda, Mrs. Brenda allocated to buy calculators? It's a pretty meaty scenario, right? Pretty meaty. Okay, one that needs to be reread. Okay, because a lot of English. All right, and I think To be honest and to be fair to our first additional second language speakers of English, the downside to word problems sometimes is not that our learners don't know the maths, right? The downside is just the inability to be able to interpret the English and then let the English make sense so that the maths can speak into the English, and then we can actually have mathematics unfold, and then us solving seamlessly a problem when it is required. That is basically the challenge here, you see. I think primarily we face that challenge for first additional language speakers of the English language. Yeah, but now we can't use that excuse anymore, right? Because I suppose that, yeah, we need to kind of acclimatize, adjust, make adjustments accordingly. So let's read this scenario again. Brenda did what? Allocated an amount of money to spend on calculators that she will donate to a charity organization that provides children with stationery. She is considering, or she considers, two different brands. Brand A are your Casio calculators, and they sell for 300 Rand each. Brand B, your Sharp calculators, they sell for 500 Rand each. If she chooses brand A, okay, she can buy 16 more calculators than she can buy if she chooses brand B. The question is, how much moolah or money has Brenda allocated to buy the calculators? Okay, and that is basically the question here. Okay, how much money has Brenda allocated to buy calculators? Okay. Now, there's something I just want to touch on before I really explore this question. Okay, and the thing is, without this back knowledge, many learners they tend to really struggle with word problems, because from grade 8 and 9, yes, definitely, Brenda, you've gotten it down there. I'm gonna be with you now. Okay, I just want to explain something. There is this topic in grade 9 that is called rate, and what rate is, guys, it's simply the comparison between two or more quantities of different types. Okay, the comparison between two or more quantities of different types. Okay, yeah. More famous and common when it comes to rate type problems is the calculation of the rate speed specifically. Okay, speed is a rate because when we talk about speed, there are two components that we compare. Two components, in other words, two quantities that we compare. Right? And those two quantities are what? When we are talking about speed, we are comparing two quantities, and those two quantities are simply what we refer to as, you know that speed is in kilometers per hour. That is the unit of speed. So the two quantities that we compare are actually found in the actual unit itself. Kilometers is compared to your hour, and therefore kilometers stands for distance, whereas hour is time. So yes, you are 100% correct there, Brenda. When we talk about speed, we are comparing distance with and time. Okay, it is captured in the unit of speed. The unit of speed is kilometers per hour, and we are comparing kilometer, which is distance, with time. Hence, we refer to speed as the rate. Okay, speed is a rate. Okay, because itself, in order to manifest, you need to compare two quantities that have different units. Distance is in kilometers, whereas time is in hours. The comparison of both gives rise to speed. So and take note of this, speed is not the only rate that exists in the world. There are many rates. There are many things that we compare with each other using different quantities. Okay. I hope we are kind of like in the same page where that is concerned. There are many other things that we compare besides just your what? Your yeah. So I really need you guys to really lock into that and understand that. So as a general approach, if ever you have a rate scenario, this is the general triangle to consider whenever you have a rate scenario. Rate will be represented there. Quantity, the QA means quantity A, and then we have QB, which stands for quantity B. Because remember, what did we say? Rate is the comparison between two quantities of different types. So I'm just going to be specific. Rate is the comparison between two quantities of different types. So the rate will compare the two quantities. The one quantity divided by the other one will basically give rise to what we refer to as our rate. Okay, so this is so important, because when you understand this, okay, then it will help you see that, okay, even with distance, speed, and time, we can use this general triangle. Let me show you how. So for instance, speed, as I said to you, speed is the what? It is the rate. Okay, that compares distance with time. So that means as the rate, where would speed be located in this triangle? It will be located here. We would put speed there because rate belongs there. Then listen up. This is kilometers per hour. So our first quantity is the quantity that appears first in the unit of the rate. Our first quantity is the quantity that appears first in our unit. So in our unit of speed, which is kilometers per hour, the quantity that appears first is kilometers. Therefore, kilometers is going to be the quantity, which obviously represents distance, which will be quantity A. Where does quantity A belong? It belongs there at the top. Then hour is the second quantity that appears in my unit. So therefore that quantity belongs where? Here. So I can then formulate what is the calculation formula that I will use whenever I'm required to calculate speed, for instance. If I'm calculating speed, I simply hide speed, and then I said speed is distance divided by time. That's what speed is. Makes sense though, because you say kilometers, you think this forward slash, what does it represent? It represents the division line. So kilometers per hour, kilometers at the top, hours at the bottom. What about when I want to calculate time? Time will be equal to distance at the top over speed. Distance over speed. T is equal to D over S. What about distance? Distance, when I want to calculate, is actually, now, the difference here is that S and T are next to each other. So we then say speed must be multiplied with time. These are the three formulas that arise from the comparison. Okay. And this triangle will assist you time and time and again, not just with distance, speed, and time with the formulas where speed as a rate is concerned, but where others are concerned. Barbarian 56, whether you are done with maths or not, that is not why I'm doing the live that I'm doing. And if, Barbarian, you are like my students, some who did not do well, even the kids in my class that got full marks for their controlled test, okay, they know very well that I've told them that they cannot be complacent just because they are done with exams, with the controlled tests. Now more than ever, a learner who knows that June exams are coming up, that the content of term 1 is going to be tested during your June exams, that there won't be sufficient time to revise during term 2 because you'll be so busy with term 2 work. That learner needs to make sure that they go back to term 1 work during the holiday and grab your question paper, grab your answer sheet if possible. If your teacher can actually take a photo of the answers and the methods you used in answering your individualized question paper that you wrote at your school, you begin to identify areas of strength which you need to polish that much more during the holiday. Continue to practice so that the maths in your mind is sustained. 2, you need to also be able to close the gaps of areas of weakness that you identified from the test. And then 3, when you were going to write the test, you know very well that there were some things that you thought to yourself, you wish that they do not come in the paper. Because if they do, they will end you. Those very things are the things that you need to make sure that during this time that you now have, that seems to be open and free, to make sure that you do not leave room for you to be in a situation again where you wish that certain questions won't come out. And then you have blind spots, my guy, my girl. There are blind spots everywhere. Blind spots, things that you are not even aware of. So if you are someone who cares, you will make sure that you are even better equipped and prepared come the June exams. So you cannot leave anything, any room for something to be amiss when it comes to your June exams. So you can type in the comment section all you want that you are done with the exam, with maths. But I wonder, if you are just going to chill now for the rest of the holiday and then schools reopen and you want to run with fire and passion, next term, I wonder how that is going to pan out for you. And I wonder also, do you want excellence to actually be the order of the day when it comes to your performance in term 2, or do you just want to get mediocre marks? Because I guess whoever I'm speaking to right now, I'm not speaking to the learner who indulges in mediocrity. I'm talking to the learner now who really wants to excel, because they know this is one of the gateways for their future opportunities in life. Varsity access won't happen any other way, and all these other things. So I'm just saying that I think that attitude needs to leave, that one of saying we are done with maths, as if to say you are done. You are not done. And I'm telling you, if your mind is going to be careless to say you are done, yeah, I mean, the maths is going to be done with you before you are done with it. So yeah, I just wanted to say that I need to get that off my chest, because I care that you guys excel. I said maths gamers should be people that aspire for 95% to 100% this term. I'm not speaking any other language when I speak to maths gamers. Maths gamers that join my life, I'm not talking about passing for the sake of passing or mediocre marks. I'm talking about excellence here, because opportunities that others are basically letting go of because of their mediocrity. Tina, we need to access those opportunities. Finishing, Clara. Anyways, let me continue. I lost the trail of what I was saying before I saw this comment by Barbarian56. Anyways, back here, guys. So this triangle now, all right, is a representation of any type of rate that you will ever be given. Because if you know the rate, what it is in the situation that you are in, then in that rate you are going to see the manifestation of, like, it's like, for instance, if you are talking about petrol, the price of petrol, the rate, right? It's rand per liter, ne? Rand per liter. Now, you may not necessarily quantify what that actually means, but let's say we say it's the cost of petrol, right? It's something rand per liter. So if I use this table, this cost represents the rate, the price of petrol, right? So what I'm going to do is that in my table, guys, I know who belongs where as per this rate. Who belongs here, 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 all right? It's obviously the rate, which is rand per liter, okay? Then here, we are going to have the price, you know, the specific price, because rands represents an amount. So we can just say maybe an amount in rands at the top. Because remember, our first quantity represents the quantity that is supposed to be quantity A. Then per liter. Then here at the bottom, we are going to have liters. You see? So all in all, what I'm saying, we can always use this rate, quantity A, quantity B, to basically represent whatever rate they may be speaking about. So the rate of petrol consumption, for instance, the rate of petrol consumption will be there. Then, of course, that is the price in rands. Okay, and then this is the liters. All right, the liters. Does that make sense? Liters. Mohammed, if you already failed, the question is, are you going to continue to fail? Are you going to continue to fail in the next term? And if you failed, what does failure mean to you? How do you utilize failure to help and assist you to identify the areas that you are weak in? Or not only just the areas where you are weak in, the things that you are doing that are leading to the failure. Guys, failure is a good thing. Failure is not a bad thing. Failure is good, because life is full of failures. I'm a drawing person anyway. It doesn't matter even if you're a drawing person anyway, my guy. The reality of the matter is, you care if you are writing, if you are doing subjects, maths and maths literature and all of that. You still care about the fact that you do well in your maths. Okay? Yeah, Mohammed, the 52% for accounting, is that what you want ultimately? Is that what you were shooting for when the year began? Was that in line with your New Year's resolutions that this year, academically, I want 52% for accounting? Because if you did not hit the mark, if you did not attain that which you had set as a target, that in and of itself is failure. That failure needs to translate in you identifying where things went wrong. Okay. You have the holiday to actually identify where you went wrong. You need to grab that accounting paper. You need to go to your teacher in the next week if you are still going to school and actually intentionally go to the teacher and say, teacher, in this paper, which areas do you think I need to work on? I think you know as well the areas you need to work on, given the fact that you were the one that wrote. And as you wrote, you kind of had a very good feeling of, I'm not so strong in this area. I'm not so strong in that area. I need to work on that. I need to work on that. So all in all, what I'm saying is that the failure, that's fine. If you already failed, then great. Take the failure, draw the lessons that you need to learn, and then do what needs to be done to correct those things so that there's no gaps come your June exams. You're going to be writing June exams, term one work, guys. And if you are still ill prepared, if you are going to be doing the same things that you did in preparation for your control test, then you are going to get the same result. Things don't just change. They don't just change. People need to be intentional about change. Yeah, I'm going on rants here, because people are commenting. Okay, so that's fine. So what I was saying here, guys, is that when you have a particular rate, you can decipher it into the table that basically says your rate belongs there, quantity A of your rate belongs there, quantity B of your second quantity in the rate belongs there. So just like this belongs there. Then if you are going to compare, if you're going to represent liters, you can represent liters in terms of the price over the rate. If you represent rate, you can represent rate in terms of the price divided by the liters. If you represent the price in rands, you can represent it in terms of rate times the liters. So the formulas then are able to emerge from this table. This is a useful table. It helps a lot in so many scenarios. I just wanted to actually come and talk about this very important thing. Very important, guys. I cannot overstate. Okay, so yeah man, rands top, liters bottom, rate there, because rate here, rate is rand per liter. It's a rate, this thing, the rate of petrol consumption there, the price, you see. Okay, anyways, let's go back to Brenda's calculator scenario. One more time, let's read the scenario, and then you'll see what I'm trying to get at here. Brenda allocated an amount of money to spend on calculators that she will donate to a charity organization providing children with stationery. She considers two different brands. Okay, brand A, you see my collection of information will be these brands. Brand A, Casio calculators, they sell for how much? 300 each. 300 rand per calculator. So this is like the price of a single calculator. All right. Then brand B, the Sharp calculator, all right, sells for 500 rand each. Guys, this is like 300 rand per calculator. This is like 500 rand per calculator. I hope you can see here that already this is a price, but it is a rate that we are being exposed to. This is the rate that each calculator is going by. All right. I hope you can understand it. Brand A, the Casio calculator, sells for 300 rand each. This is like 300 rand per calculator. So we have rand per calculator. Are we together here? Hey guys. Eish. Me, I try to reveal things. I'm telling you. Brand B, sells for 500 rand each, 500 rand per calculator. Anyways, let's go on. If she chooses brand A, she can buy what? 16 more. So if this guy chooses brand A, she can buy 16 more. Brenda, this young lady, vivacious lady, if she chooses brand A, she can buy 16 more calculators than she can buy if she chooses brand B. How much money has Brenda allocated to buy calculators? Okay. Yeah. How much money has Brenda allocated to buy calculators? So that is like the total amount, the total amount Brenda would have allocated. Very good, Brenda. So yes, Brenda, you are 100% correct. We can let X be the amount, the total amount, exactly, actually. The total amount that Brenda has allocated to buy calculated. I like that. I like how you think, Brenda. Okay, 100%. Let X, we define variables as such. Then I'm going to utilize the table because from what I can see, we have two prevailing brands. Okay, we have our Casio calculator. Our scenario is very clear, and we have our Sharp calculator, brand A and brand B. Brand A is the Casio, brand B is the Sharp calculator. Okay, then we have that total amount that's allocated. Okay, so Brenda already said we let that be X because we don't know. All right, then we have that rate, or like the unit price, right? It's like per calculator. Okay, that rate. Okay, the Casio calculator goes for how much? 300 rand each. So we are going to write 300 rand each. Then the Sharp calculator goes for 500 rand. So we put that 500 rand there. Now please take note, guys. We are not told how many calculators. Okay, so this here would be the calculator quantity, like how many. All right, it's like the quantity of calculators. Now remember, I spoke earlier on and I said this here 300 rand per calculator. It didn't say 300 rand per calculator, but if it says 300 rand each, then we know the rand here represents the total amount, and then C represents the calculator. So we can actually just come here just very quickly. I want to show you this, guys. The rate we know was quantity B and quantity A. We know that quantity A is going to be the total amount. It's going to be that amount. Okay. Whereas here, quantity B is the number of calculators. Okay. But since we have the total amount in terms of X, because we let X be the total amount allocated to buy calculators, and the rate we already have for that specific calculator, then it means to get, remember, this is the rate, this is quantity A, and then this is quantity B. So if I'm going to represent quantity B, then I'm going to come here and say, what is quantity B? Then I can use my table and say the total amount divided by the rate. Total amount divided by the rate will give me the quantity. I repeat, total amount divided by the rate will give me the quantity. So the total amount, which means X over 300. Guys, do you understand? X over 300. Quantity B. Guys, this is quantity B. Okay. Now, you may now probably wonder, why did I spend some time going over this? The concept of rate. The concept of rate. Why did I spend time, guys, going over the concept of rate? Oh, yo, it's holidays, booty. Whoa, no, it's not holidays. Schools close next week, Friday, officially. That's one thing. Two, if you're going to have a holiday, and it's going to be a holiday without you taking stock of some of the things that you have done, then good luck to you and getting excellent marks come term 2. All right? Yeah. Please, if this is harassing you, please move on to the next live, please, guys. Don't stay if you are being harassed by my live, because you want to kick back and relax. Kick back and relax. Don't allow me to harass you. Okay. So do you see, guys, why I insist on the triangle, the rate, understanding the rate, what it is? 300 Rand each. That is basically my rate. The total amount represents quantity A. And then the calculators, the quantity of the calculators, I am going to get by saying what? X over 300. Then let's move on to the sharp calculators. What is going to be the quantity of the calculators? I'm going to get it by saying X over 500. My table is ready to be utilized. All right. And I'm going to utilize it now. All right. By rereading the statement and then setting up an equation using the information that I have just amassed and put together. I am now going to reread, and then I'm going to set up a nice proper equation for me to solve, so that at the end of the day, I can be happy about what I have done. Okay, so let's look at this. If she chooses brand A, she can buy 16 more calculators. You see, now we are basically looking at this column. If she chooses brand A, the quantity of calculators for brand A is X over 300. So it says, if she chooses brand A, she can buy 16 more calculators. Let me just show you what that means. If she chooses brand A, in other words, X over 300, that is brand A. If she chooses brand A, there's brand A. If she chooses brand A, she can buy 16 more calculators than she can buy if she chooses brand B. If she chooses brand A, she can buy 16 more. Now, guys, mathematically, what does 16 more mean? Guys, please listen. 16 more. If I have 3 sweets and then you give me 16 more, what does that mean? If I have 3 sweets and then you give me 16 more, what does that mean? How many sweets do I have? I have 3 sweets. You give me 16 more. What does that mean? I hope you understand what that means. I have 3 sweets in my hands. You give me 16 more. No. I definitely will not have 18 sweets, Brenda. Okay, you are close to the answer, but just one away far. Okay, if I have 3 sweets, you give me 16 more, then it means how many sweets do I have? Yeah, exactly 19. So the word 16 more means plus what? Plus 16. So let's reread this statement again. If she chooses brand A, by the way, brand A is X over 300. That is the quantity of calculators, X over 300. This variable rate or this variable quotient. Yeah, I think that's the most appropriate word, because it's not, this variable quotient x over 300 represents the quantity of calculators for brand A. Now it says if she chooses brand A, what can she do? She can buy calculators. She can buy 16 more calculators than she can buy if she chooses brand B. That means x over 300 is equal to x over 500 plus 16. That's what this thing means, guys. That's the setup of the equation. If she chooses brand A, this is brand A, she can buy 16 more calculators than she can buy if she chooses brand B. This is like literally how you read and then write out your equation as per the statement. If she chooses brand A, who is brand A? X over 300. She can buy 16 more calculators than she can buy if she chooses brand B. So it's x over 300 is equal to x over 500 plus 16. The equation has been set up. Now, with the equation set up nicely, you can now solve, because all of this was referring to, the reason we are focusing primarily on this column is because we are dealing with the quantity of calculators. If our knowledge of rates was not up to speed, we would have easily not been able to even have this column of this particular quantity of calculators, and we wouldn't have been able to understand that there's a relationship of x and 300 that actually is the relationship between the rate, which is 300, and quantity A. We know that the relationship between quantity A and the rate is one of division. Quantity A divided by the rate. That gives us quantity B. So for each calculator, we could get the quantity of the calculators by saying the total amount divided by 300. For the Casio calculator, the total amount divided by 500. For the Sharp calculator, our rate conceptual knowledge is assisting us here. Then, as we read this statement, if she chooses brand A, she can buy 16 more. 16 more means plus 16. 16 more calculators than she can buy if she chooses brand B. Then she can buy 16 more calculators than she can buy if she chooses brand B. If she chooses brand A, there's brand A, she can buy equal 16 more calculators than she can buy if she chooses brand B. 16 more. Okay. Equation is set up using the quantities because we are associating it with the other quantities. Now we can solve for x, guys. And what's nice is that the x is there because we incorporated it in the quantity of the calculators. Now we can solve for x, guys, and we can do so obviously applying our knowledge. So whenever we solve for x, guys, when there's fractions, what do? We look at the denominator. This is 300, this is 500. We find the LCD. Why do we find the LCD? Because the LCD, when we find it, we use it to eliminate the denominator so as to be able to solve the equation either linear or quadratic. So the LCD between 300 and 500 is going to be 1,500. So then you multiply 1,500 by each fraction. and term. Plus 16 times 1,500. Okay, sorry, let me turn over the page so that you can see this properly. So we have x over 300, which is multiplied by 1,500, is equal to x over 500, which is multiplied by 1,500, plus 16, which is multiplied by 1,500. All these 300 goes into 1,500 500 times, so you have 500 times x, which is equal to 1,500 goes 500 goes into 1,500 how many times? Actually not 500 times, what did I say? 300, sorry, goes into 1,500 5 times. What am I saying? So it's 5 times x. 500 goes into 1,500 3 times, so it's 3 times x. And then 16 times 1,500 is 24,000. Okay. Then 5 times x is 5x, 3 times x is 3x plus 24,000. Then you solve for x. You take the 3x over, you get 24,000. Okay. And then what's 5x minus 3x? It is 2x. And that's equal to 24,000. Okay, and then after that, what do you do, guys? You divide both sides by an amazing, phenomenal 2, and then you get your x value, which is 12,000. That 12,000 is 12,000 rand. Okay, that means Brenda allocated, Brenda, you allocated a lot of money. 12,000 rand you allocated, my dear, to buy calculators. Okay, that's the amount of money you allocated, my dear. You allocated that amount of money to buy calculators. You don't mess around, do you? Charity organizations are just your thing. Okay. Yeah, please, guys. Yabo, give rate into a rate, right? Rate. So this rate thing, so these questions that have your rate encompassed in them, for your table to be set up properly, my people, the comprehension and understanding needs to be there. Okay, if it's not there, then it's easy to basically fumble these questions, or maybe even skip them and not answer them, because you are like, some questions are made for other people. What a sad conclusion to make. It's not true. Questions are made for all people to answer. The capacity, the capability, and the ability to be able to answer question lies in each and every person's capacity. You are able, you are able. So please, guys, so hey, I know man, these problems, they are nice. Okay, let's look at another one, just one last one before I vamos. But there's also distance, speed, and time type problems. Guys, the distance, speed, and time problems, they are the same. It's a matter of looking at the situation and identifying those things that need to be identified using the table. So the ones that have rate, table is the best. Table is the best. The minute you can see, but hey, this one, there's rate involved, then you must table setup, my guy. Very quick table setup. Okay, let's see who else is here. Let me try. We're going to use Brenda again. I want to put another scenario. Let's take this one. Okay, I'm gonna do 2 last ones. Okay, that have different scenarios. Katlego travels from town A to town C. The minute we are traveling, it means we are going to be speeding up, we are going to doing also via down A to down C via down B. The distance from down A to down B is 200 kilometers. (200 kilometers) more than the distance from down B to down C. Katlego drives at the speed limit. Yes, Katlego has a license now. It's driving like crazy. It seems like Katlego. You use people and then they like, stop using me. Katlego drives at the speed limit of 120 kilometers per hour. Between down A and down B, and reduces her speed. You left speed in the mind. Or is it? Whatever drives at the speed at the, talk about it. Thank you for that. Drives at the speed limit of 120 kilometers per hour between town A and town B, and reduces, what does she do? She reduces her speed to the new speed limit. Of 80 kilometers per hour between town B and town C. The entire journey Yes, guys, the word problems for distance, speed, and time tend to be very wordy. And I think it's in the moment when the questions become wordy that people are like, me, I cannot fathom, okay, I cannot father this with these words, and then people just abandon. The entire journey from town A, the entire journey from town A to town C takes 5 hours. What is the distance? What is the distance from town A to town C? That's my daughter. What daughter? Which daughter is that one? That's your daughter? That what? Sorry, I missed that because I was busy focusing on the writing. I think I might have left my trail of thought somewhere lingering, and I did not get what I was saying and its relevance to what you just typed in the comment section. Okay, Katlego, KT, Katlego. Right. All those questions that you're asking there, Brenda, are very relevant and good. Okay? Yeah. Remember that we primarily deal with time in terms of hours. The only thing we would convert to something else would be if we are given time in minutes, then we'd have to convert it to hours. But if our time is already given to us in hours, then we are in good ground. We are in a safe place. Okay, then there's no issue. The issue is basically catered for. Katlego travels from town A. Let's reread this. Katlego travels from town A to town C via town B. So in my head, I'm just trying. Is it? No. Katlego, remember, I hear what you're saying, right? But that depends also on the question. If they want answers to be given in minutes, if they tell you, if there's a directive to give your answer in minutes, then definitely you will convert things to minutes. But in this particular scenario, remember, if we have the rate of speed and it's given in kilometers per hour, then we need to actually stick to that particular unit of hours and not convert the hours to minutes, so that we can actually have the integrity that hours would allow if that unit is being used in the rate as kilometers per hour. If ever we reduce the hours to minutes, then it would simply mean that we are not talking about kilometers per hour, we're talking about kilometers per minute. And really and truly, that does not fly. Okay, kilometers goes with hours, meters goes with seconds, right? So it's meters per second, kilometers per hour. Those are the units that actually correlate. Okay, so in this situation, retaining hours as they are is fitting. Okay, so Katlego travels from town A to town C. Yeah, let's just say town A and town C via what? Town B. Let's just say town B is somewhere there. It's just so that we can have like a visual of this. The distance from town A to town B, we are told, is 200 kilometers. No? 200 kilometers more than the distance. Oh, sorry, it's not 200 kilometers, but it's 200 kilometers more than the distance from town B. Let's reread this again. The distance from town A to town B is 200 kilometers more, okay, than the distance from town B to town C. Okay, that makes sense. Do you see this, guys? Okay, so let me just rub that out and just down A to town C via town B. Okay, yeah, so it seems like our scenario is going to be divided into the towns, okay, the distance between the towns. So let's just look at this again. Katlego travels from town A to town C via town B. The distance from town A to town B is 200 kilometers. Distance from town A to town B is 200 kilometers. The distance from town A to town B is 200 kilometers more than the distance from town B to town C. So that means the distance from town A to town B is actually, let's say we let the distance of, because if they are saying here, the distance from town A to town B is 200 kilometers more than the distance from town B to town C, then it means town B to town C's distance, guys, we can let X be the distance from town B to C. Does that make sense, guys? Yeah. I guess I get your point, Z. I get your point, Z. And the thing is, that's not my intention, right? That's not my intention. I was just trying to just have a mental representation. Okay, the whole idea of doing this is not that I do that, but it's just that, yeah. But I get you. I get what you're saying. So let me just be maybe a little bit more authentic then. See, since you are saying that, I appreciate that comment. I really appreciate it. It helps me a lot. So can we then agree we are going to let X be the distance from town B to town C? That is going to be X, because we are already told that the distance from town A to town B is 200 kilometers more than the distance from town B to town C. So I can say the distance from town A to town B is 200 plus X. Or maybe more well put mathematically, as per what is being said in the statement. If they're saying the distance from town A to town B is 200 kilometers more, then it means that BC's distance, which is X, we just add 200 to that distance, because it will give us the distance of town A to town B. Does that make sense, guys? So these expressions are both correct, because we know that anyways addition in mathematics is commutative. What do we mean that addition is commutative? It means that the order in which I place X and 200 when there's addition don't really matter. 1 plus 3 is the same thing as 3 plus 1, in other words. Okay, but do you guys see that letting X be the distance from town B to town C is the way to go? Then we can then talk about the distance of town A to town B in terms of that distance of X by saying, because they said that the distance from town A to town B is 200 kilometers more than the distance from town B to town C, then we can say that that distance is the X plus 200 means 200 more than this distance. Okay, so it's X plus 200. So now I'm going to go to my table, because I feel like a table is brewing here. Okay, it seems like the two predominant scenarios I have here is B to C, the distance from town B to C, and the distance from town A to B. That is my two major scenarios, right? So let's look first at distance, because that is one of the units that is there. The distance, okay, B to C, we agree is X, because we did let X be the distance from town B to town C. Can I just get an amen from those who've been here since like the beginning of me writing this scenario, that we actually understand why I said we let X be the distance from town B to town C, and then we express the distance of town A to town B in terms of X, because we are told that the distance from town A to town B is 200 kilometers more than the distance from town B to town C. So if that is the case, I have two expressions, but also that exposes me to the two scenarios which I can tabulate, all right? Because I can speak about the distance of town B to town C, it's X, but the distance of town A to B is then going to be X plus 200. So I'm so happy because I have beautiful expressions here. But that's not the only thing with what I have here. Let's go read further. Katlego drives at the speed limit of 120 kilometers per hour. So we have speed now. Speed limit. And that speed limit is our rate, guys. Speed is rate, right? 120 kilometers per hour. 120 kilometers per hour. Okay, let's read further so that we don't. So let's read. Katlego drives at the speed limit of 120 kilometers per hour between town A and town B. Yo, this is specific. Town A to town B, Katlego is cruising at 120 kilometers per hour. So where do we put the speed there? 120 kilometers per hour. That's our rate. Then let's read further. And reduces to the new speed limit of 80 kilometers per hour between town B and town C. So between town B and town C, new speed limit 80 kilometers per hour. The last quantity is time. So let's read so that we can see what we have as far as the time is concerned. But let's be note careful about the fact that we are interested in knowing what the time is from A to B and B to C. We want to be able to represent that. Okay. I must bless you with ring light. You are a hilarious woman. My goodness. Oh, my soul. Hey, what's the... Yeah, I was still trying to use what you might call the street light. Just the natural light. I don't want to bring in the whatever. Okay. I appreciate it. I'd really appreciate it. I mean, it would be very kind of you. Zizi. All right. So anyways, the time, right? So let's read just to see if there's anything that's contained in the scenario. If not, as far as, or with a stand that is, that would be amazing actually. Then Z, I'll tell you this. I've got a whiteboard here, to be honest, which I can probably then utilize very nicely, you know, utilize very nicely. Then I can start doing my lessons, like literally, like, you know, with the stand and stuff. Imagine. Anyway, sorry, let's go back. The entire journey from town A to town C takes 5 hours. Oh, so this 5 hours is for the entire journey. Okay, so this 5 hours is not going to feature here anyways. Okay, the entire journey takes 5 hours. What is the distance from town A to town C? That's fine. We are going to come back to that entire journey stuff. So our time then, that is where now the table comes to help us. The triangle table. Speed is rate. Since it's in kilometers per hour, the kilometers is our first quantity. Quantity A. Time is what? Quantity B. So time as quantity B, because it's the second quantity in our rate, all right? We go here and we're like, what is the expression of quantity B? It's quantity A over the rate. What's quantity A? X plus 200. So we're going to say X plus 200 divided by 120. Hey guys, that is the expression of time using the information that's in the table. Hey, man. Guys, if one problem is not coming to light for you, I don't know. You know, my grade 10s and 11s cry about word problems all the time, but they don't know that all of that is actually like contained. Yeah, it's contained. I will have it. Z, that third row is going to be for the setting up of our equation. That is the whole point now. The setting up of the equation. All right. Yeah. So I don't usually normally have that written down because I know I'm just going to go and reread the entire scenario so that I can set up my equation using that entire journey understanding. Then here, what about this one? Quantity B. Yeah, quantity B, QA over the rate, meaning X over 80. So now here I have time, guys. What did they say now about time? The entire journey. No? The entire journey takes how long? 5 hours. So what does that mean? There we have it. From A to B, that's the time. From B to C, that's the time. The entire journey in total. When they say entire journey, it means the from A to C. So I can set up an equation and say X plus 200 over 120 plus X over 80 is equal to what? 5. the addition of my hours, the entire journey from A to B, this is how long it took. From B to C, this is how long it took in terms of X. But then the entire journey in total is 5 hours. So I'm going to add these two, equate it to 5, and solve for X. That is basically how we utilize the information, fully, so that we can solve and work it out. This here is all algebra, my guys, all algebra. So it's important, this thing, let X be the thing that you mean. Then you use your table to then fill in your information. And then if it's a rate, guys, you just make sure that you use your rate, all right, to be able to fill in all the other information. Imagine if I did not have an understanding of this idea of rate, then would it have been possible or feasible for me to be able to have this column easily and seamlessly? Probably not. And then I would cry all the time, say word problems are difficult. But the concept is the concept you learned in grade 8 and 9 on rate. That's where it's hiding. That's where the mechanics and the intricacies of solving this equation are hidden. So once you understand that one, Max Gallo. So now all you do now is solving an equation. So you find the LCD between 120 and 80. Guys, obviously, between 8 and 12, you are finding the LCD between 8 and 12, you know it will be 24. Okay? You count in 8, 16, 28, 16, 24, 12, 24. So it's 240, the LCD. Then all you do is you multiply by 240. Everything. You see? You multiply by 240. Why are you multiplying 240? To eliminate the denominator. You see? And then 120 goes into 42 times. So you are left with 2 into 2x plus 200. 8 into 40 goes 3 times. So it's 3 times x. And then 5 times 240, is 1,200. Just like that. Then you solve for x, guys. Distribute 2x plus 400. So important, guys, that when you have binomial terms in your numerator, you ensure that you put them in brackets so that the resulting value that gets left behind gets distributed completely to the two terms. If you don't have brackets, it's easy for you to think that this 2 is only supposed to be multiplied to x and that's it. And then when that happens, your answer is going to be incorrect. It's not going to serve the purpose of you having done all of this hard work. All hard work for nothing. Hi guys, we can't do that. 2x plus 3x, we get 5x. We take the 400 over, it's 1,200 minus 400, we get our beautiful 800. That side, 5x, divide both sides by 5, we get x is equal to 160. That 160, remember, is what? It's the value of x. What did they want from the beginning of the question? They wanted us to what? The entire journey, town B, from town A to town C, takes 5 hours. What is the distance from town A to town C? So they want the total distance. Okay, so that means you are going to come here. Total distance. You will take x plus 200. You will add x. In the place of x, you substitute 160. And then in kilometers, the answer will await. 160 plus 160 is 320. 320 plus 200 is 520. Then you can conclude the distance from town A to town C is 520 kilometers. You conclude, my guys, you conclude very sweetly and nicely, so that even the person who was marking is like, this boy, this girl, this woman knows what they are talking about. No more word problem phobia. Easy peasy, easy. All right. Please, guys, please, for the love of word problems, let me close with the last word problem, and then me is going to call it a day. Okay, I know the sum of the digits of a 2-digit number is 10. The sum of the digits of a 2-digit number is 10. If the digits of the number are reversed, the resulting number is 54 less than the original number. Determine the original number, or determine. I know some people are like, they insist on determine the original number. The sum of the digits of a 2-digit number is 10. If the digits of the number are reversed, the resulting number is 54 less than the original number. Determine the original number. Now, these are basically questions that revolve numbers, okay? And this is a sweet, nice example whereby we can basically see that sometimes our word problems lead us to a simultaneous equation situation, okay? Yeah. Oh, Brenda seems to be fluent in these problems. You've been commenting a lot in the comment section, Brenda. Fluency is you, ne? Fluency is you. You are fluenting. Hey, Brenda, tell me something. Hey, Umdaze, in this profile picture of yours, you are chowing something there. Hey, yes, son. Hey, hi, Brenda. You are fastering, I'm telling you. Okay, sum of the digits of a 2-digit number is 10. Okay, and that's your mom. Oh, sorry. My bad. I thought you were chilling. You were chowing there. It was you chowing. Of course, I wouldn't know, right? I wouldn't know if it's your mom or if it's you. I wouldn't know, right? Me, I'm gleaning from the profile pictures. Sometimes I assume from profile pictures. My assumptions are the worst, but I guess it's the best I have, right? I have no other source of information as far as knowing. I wouldn't know any other way, but I get you. Okay, yeah, mom is chowing very nicely. You must really love your mom to make her your profile picture chowing something. Yo. The sum of the digits of a 2-digit number is 10. The sum of the digits of a 2-digit number is 10. I hope you guys are noting what is being said here. The sum of the digits of a 2-digit number is 10. So I'm just trying to imagine here. Let's say this digit was 56. Sorry, let's say this digit was 64, right? I'm just saying. So they are saying that the sum, okay, the sum of the digits of a 2-digit number. So 6 is the first digit, and this 6 occupies what we call, if you are in grade 10, if you're in grade 7 and 6, we call these the tens column. Then the 4 occupies what we call the units column. So these are the tens. We call this the tens column, and then we call this the units column. So in other words, 4 is units, 6 is tens. So in other words, what they are saying in this problem is that the sum of the digits, in other words, the sum of 6 and 4. I'm not saying it's 6 and 4, but what I'm saying is they are saying the sum of the digits of a 2-digit number. So this is actually a 2-digit number. The number itself is a 2-digit number, but it is composed of 2 digits, right? So they are saying the sum of those 2 digits gives you 10. Just like, for instance, 6 and 4 would give you 10, but the digit number is 64. Does that make sense? Yeah, because I'm trying to really unpack the meaning of what is being said in the statement so that you and I can be able to then set up things correctly. I'm not saying usually means he's saying that. Asuka. Asuka. Ziga. 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 Zigi. Sugazi. Zizi, you are Zizi. You are Z. Z, you are a funny one, man. Okay. Some of the digits of a 2-digit number. By that I mean by adding the numbers, yeah. Okay. Yeah. Okay. So that's where we need to be alert and awake, because the sum of the digits of a 2-digit number is 10. So these digits, all right, we don't know what those digits are. So because it's a 2-digit number, okay, and the 2-digit number contains 2 numbers. There is the tens number, there is the units number, because a 2-digit number contains tens and hundreds. A 3-digit number contains hundreds, then tens, then units. You must understand that the number itself here, 6 represents the tens number, 4 represents the units number. So basically they are saying the sum of the digits of a 2-digit number is 10. So what are those 2 numbers that we are going to be adding together to get 10? We don't know them. We are going to let X and Y be the tens and units digit respectively. Now let me just alert you of something. Learners in grade 8, 9, 10, 11 don't know these basic concepts of tens, units. They last did those tens, units, column stuff in grade 7 and 6, which was in primary school. So oftentimes what examiners do a lot of the time is that in their questions that they ask, some of which tend to be complex for learners that are in grade 12 and in 10 and 11, they will put in these sorts of questions where units and tens, a unit digit, and people don't even know what a unit digit is. So please guys, whenever we talk about a unit digit, we are talking about that number. Okay? Yes. The variables are different because they did not say in the statement the sum of the digits of a 2-digit number that has the same digits is 10. They said the sum of the digits of a 2, the sum of the digits. So they've kind of like opened it up to say they are digits. We are not told specifically, are these digits the same? Because remember, if they had said the sum of the digits which are the same of a 2-digit number, then we would have basically said, let those 2 digits both be x, because they are the same. But since we don't know the specifics and they have opened it up, we are going to say let x and y, x be the tens digit number and then y be the units digit number. We let x and y be the tens and the units digit respectively, because we can only take it that they are different, not take it that they are the same. Because if they are the same, they should have explicitly told us that they are the same. And in that way, we would have let both the tens and the units number be x, or let both of them be y. Okay, I hope that makes sense and you understand it for what it is. Yeah? Now, let's continue. Let us continue. The sum. Okay, so once again, okay, I hope, I'm glad you understand. Thank you. I'm glad you do. Okay, now the sum of the digits of a 2-digit number is 10. So in other words, they are saying x plus y is equal to 10. By that, we have our first equation. Okay, by that we have our first equation. Okay, but now let's read on further. Okay, let's read on further. Yeah, thank you. If the digits of the number are reversed, if the digits of the number are reversed, yeah, because if you are going to reverse the digits of the number, okay, and reversing the digits of the number means that the units digits occupies the tens and the tens occupies the units digit number. That's basically what it means. If the digits of the number are reversed, the resulting number is what? Is 54 less than the original number. Determine the original number. Now that's very, very interesting. The way that they've sort of like worded that, okay? If the digits of the number are reversed, what is this? The reversing of the digits of the number, okay? So I want us to kind of think as to what are they trying to say? Oh my soul, what's happening? Why is my network not network? What's happening? Guys, can you, is